their identity. And in addition, also provides a nullifier mechanism to prevent users from reusing the same existing proofs. I would like to start with like the main concepts, the main core concepts of the protocol: identities, groups, and proofs. So an identity is just an ETHDSA key pair. It's like what users need to own to interact in the semaphore ecosystem. And a group is a Merkle tree used to efficiently prove that a leaf, which in this case it's like a semaphore identity, is part of the tree. Why using Merkle trees? Because they are much more efficient than using like simple lists. And the third core concept is proofs. Finally, the owner of the private key, of the semaphore private key of a group's identity can prove first that they are indeed the owner of the identity. Second, they are a member of the group. And third, the anonymous message is their message. But what is the nullifier again? So the nullifier is a special value that it identifies a proof generated for a specific scope from a specific user. So that first, if the user generates another identical proof, that proof is considered is not considered valid, as there is already a nullifier of it saved somewhere. And second, no one else can reuse existing proofs again. So the most interesting thing, property of this protocol is that it is general purpose. So it's it means that all use cases where anyone needs anonymity or privacy can benefit from using it. I would like to talk shortly about two key aspects to consider when building an app with semaphore can be interesting. So first, in the end, what the group users are, what they are going to prove is the ownership of what they use to join the group. In other words, the proof generated in semaphore doesn't just confirm group membership, but also indirectly proves the user possessed the credentials required to join the group at the time of registration. And you have total freedom, of course, to choose what these credentials can be. They can be like an invite code, an NFT, a passport, a certain balance on Ethereum, whatever you need in your application. And the second key aspect of this protocol is that the challenge is here is like to create groups of people who share the same credentials and save as many people as possible in those groups to increase anonymity. Why do groups need to be as larger as possible? Because anonymity is not binary. It's not something that you have or you don't have. It doesn't work like that in semaphore or in any like anonymity set. It depends on the dimension of the group. It's rather a spectrum. So a group with one person is not anonymous, of course, nor a group with two. But when we start having like groups with 3 people or more, in that case, it's anonymous. But of course, the more people, the harder it is to guess the identity tied to one specific proof. Another point is that in some cases it could be easier to build like larger groups. For example, like a group of people with a certain nationality, for India, for example. In other cases, it could be more difficult because maybe you can use more credentials together. So a group of people who have a certain nationality, who went to DevCon 3, 4, and 5, and who have more than one hackers in their wallets. In that case, it's harder to build a group, a big group. So this is something that you should take into consideration, into account when you build semaphore groups. Some use cases. So let's see some examples. Semaphore could be used to protect people's identity when they need to submit evidence for crimes or corruption. Corruption is still like a big issue in many countries around the world. It can provide anonymity when people need help in sensitive situations and want to avoid social stigma. And another classic example is anonymous voting applications. Semaphore could be used to allow small groups of people to vote anonymously and make decisions in decentralized organizations or institutions. Of course, semaphore is not always the right tool. For example, for political elections, it's more complicated. There are many variables, and tools like MESI or other zero-knowledge tools can help solving those challenges more than semaphore. For a more comprehensive list of ideas, check out the link of the discussion on GitHub. But let's go a little bit into deep and better understand how you devs can use semaphore. So let's start with the JavaScript libraries. There are 3 core libraries, but all of them have been packed in one core library. The first class you have to use is identity. Identities, as I said before, are ETHDSA key pairs. So ETHDSA is one of the most common algorithms used in snarks, and it's based on elliptic curves. Semaphore identities are made of 3 values: private key, public key, and commitment. The public key is 256 bits. It's pretty small. The public key represents a point in the curve, and it's X and Y. And the commitment is like the Ethereum address. It's like the hash of the public key. So why do we need a commitment and cannot just use the public key? Because for 2 reasons. Because the Poseidon hash that is used to hash the public key is supposed to be more quantum resistant than ETHDSA, and the commitment is just 1 number. So it's a better format compared to the public key, which is 2 numbers actually, 1 for X and 1 for Y. So in the code here, you can see that the class can be used in different ways. You can not pass any parameter and create a random identity, or you can pass a secret, like a string, and create a deterministic identity. You can also export or import your identity with these functions. And in addition, the identity class can also be used to sign messages and verify signatures. So there is another important class, which is group. The group class is an abstraction of the linear incremental Merkle tree. As you can see, it's pretty simple to use. You don't need to know any detail about the linear incremental Merkle tree. Just note that the group class can be used to create a group, add members, update members, and remove members. And I think in the majority of cases, you will only need to add a list of members. So you can use the add members function directly. The third core package is proofs. After creating an identity and creating a group, you can use these 2 functions, one for generating the proof and the other one to verify the proof. So in order to generate a proof, you need to pass 4 parameters: the identity, the group, the scope. 42 in this case is the scope, and hello world, which is the message, the anonymous message. The message can be a number, a string, or any value you can think of. So the scope here is what is used to generate the nullifier. I talked a little bit about it before. The nullifier is basically the hash of the scope and the private key. And it helps to prevent users from reusing the same proofs. Then you can use the verify proof function to verify proofs. It returns a boolean, false in case the proof is not valid, true otherwise. Semaphore also provides solidity contracts. You can use them to manage groups and verify proofs on chain in case you need correct execution or public proofs verification. It's great for building dApps, decentralized applications, but be aware that the identities, of course, still need to be created off chain because the private key is a secret value and you cannot share it in the contracts. In the Ethereum blockchain, everything is public, and proofs still need to be generated off chain. So this is a list of tools you can use with Semaphore. You can use the JavaScript libraries with the core package. There are other libraries in case you need to build something more complex. The Solidity contracts can be used with 2 packages. One is data, Semaphore protocol data, and the other one is Semaphore protocol contracts. So if you want to build your own contract logic on top of semaphore, you will need to use semaphore protocol contracts. You can see the list of JavaScript packages in the repository. There is also a CLI, and you can use the CLI to build your own project. There are some templates. All of them are based on Next.js, I think, apart from one which is like for contracts specifically. There is also a boilerplate. You can check the repo and a demo app which is based on the boilerplate. You can try it out. So yes, this is everything for semaphore. Bandada is like an extension of semaphore in a sense, and it basically provides an infrastructure to manage groups, semaphore groups, and an anti-Sybil mechanism to ensure that users are unique. How can it do that? It provides tools to create credential groups that are like groups where users can join if they meet certain criteria, like some parameters in social networks like Twitter, X, GitHub, or blockchain data, or social networks data in general. Some use cases for Bandada. So you can build groups for platforms for DAOs, groups of people in private organizations, even like using on-chain data, like wallets holding specific NFTs, or a group of members with more than 500 Twitter or X followers or whatever, or GitHub data, or number of transactions on a specific network. The interesting thing is that you can also mix like some parameters and social networks, but I will talk about it later. So some functionalities of Bandada. First of all, there are two different infrastructures, let's say. The off-chain infrastructure, which is like the one where like Bandada focus basically is focused. Off-chain means like a client-server infrastructure. The server provides APIs. You can basically create groups, update groups, remove groups, and add members and remove members. There are two access models that you can use. The admins can like allow users to join those groups by an invite code with a magic link. So they can basically create this secret code and a magic link. They can send that code to users, and users can use that code to join groups with a user interface, with a dashboard. Also, I mentioned them before, Bandada provides credentials groups to join groups. Credentials to join groups. And those credentials can be like GitHub, Twitter, blockchain, or ES. So followers, personal stars, repository commits on GitHub, followers and following users on Twitter, balance and transaction on Ethereum, and EAS attestations. Credentials can also be combined. Bandada provides logical operators and or not or XOR. You could have like a group for people who have more than 500 followers on X and like 40 contributions on GitHub and at least 10 transactions on the mainnet. You can like use many different credentials together. There is like one package you can use to like build your own credentials, which is Bandada Credentials. It's a JavaScript package. And regarding the on-chain groups, currently Bandada provides, basically it's like a dashboard to interact with the semaphore contracts. So there are not any functionalities yet. You can work with the semaphore contracts using two packages. I already mentioned them before, contracts and data. The contracts package is basically a set of Solidity contracts, and the data package is a package you can use to fetch members from the contracts. So here are a list of dev tools you can use with Bandada. The API, then there is also an NPM package that wraps the APIs if you prefer using JavaScript in your application. Bandada also provides a boilerplate, that's the repo. There is a demo app for Bandada as well. I think the demo app will be very useful for anyone who wants to build on top of Bandada and Semaphore. It includes Semaphore, of course. And okay, this is like an architecture, a simple architecture that can be useful to understand like the flow of a client-server app built on top of Bandada and Semaphore, just to show you like the flow. There are two blocks. One is the Bandada instance on the left. It's like a database with like the groups and the members of the group, a backend with the APIs to interact with those groups, and a dashboard. The dashboard can be used by the admins to, again, to create groups, remove groups, and manage them. Now, the block on the right is what you are going to build, basically, or like what you will find in the boilerplate. And it uses the Bandada APIs in two different components, the front end and the back end. In the front end, users will call the Bandada APIs to fetch Merkle proofs, which is not like the zero-knowledge proofs. It's a Merkle proof, which is like the path from the leaf to the root that proves that a semaphore identity is part of the tree. That Merkle proof is used then to generate the semaphore zero-knowledge proof. And then the proof is sent to the backend, where the server can check if the proof is valid, checking if the Merkle tree root of the proof matches the Merkle root of the Bandada group. And yeah, if the proof is valid, the server can run its logic, like authenticate the user or whatever you need to do. So this is like the list of bounties. What we would like to see in this hackathon is creative ways to use Adar data, or maybe anon Adar, with Semaphore and Bandada. So Adar data can be used as a gatekeeper to join Bandada groups, turning that data into cryptographic proofs that can be efficiently generated and verified with Semaphore. Why Semaphore is useful and could be used instead of anon Adar, for example, because it's extremely light and efficient, so you can generate proofs in less than 1 second on browsers. Another area of exploration is secure identity generation. It will be like interesting to see secure ways to derive semaphore identities from Adar data in secure environments. And then, of course, like there is room for more freedom. Like the last bounty will be won by whoever makes better use of these two projects, Bandada and Semaphore, with no particular constraints. So yes, that's it. Please scan these QR codes if you want more information about these projects, and feel free to reach out on Discord or Telegram. We will be answering your questions and supporting you during the hackathon. It's a pleasure to be here and a great opportunity to collect feedback and further improve the developer experience of these projects. Thank you very much. Okay. Can I go up? Guys?
TLS team, currently working with TLS Notary team. So in this workshop, we will learn introduction to TLS Notary, bounties for the hackathon, and the plugins and development system. So this is the kind of workflow we will follow. So just introduction, some theoretical part of TLS and Notary, a browser extension demo, and then the code part too. So first of all, what is TLS and Notary? TLS Notary is a cryptographic protocol that allows you to transfer or unlock your Web2 data and give a proof or attestation to a third party. So you can literally prove that you have, for example, proof of Steam achievements to another website, for example, Epic Games, that you have achieved this achievement or you own these games. So it works on the TLS protocol, the Transport Layer Security Protocol, TSS, HTTPS, and it works in the following way. First of all, it's not the man-in-the-middle attack. So your connection to the server is still encrypted and private with TLS security. It's not man-in-the-middle. So how it works is you have a website, for example, a bank website or a government website, and you make a TLS connection with that, and you get encrypted connection with that website. So if Alice have to prove to Bob that she has, for example, proof like this much fund in her bank account, she has to get an attestation from a notary service, or she has to ask bank or use an API or OAuth or something like that. But with TLS Notary, she can make a proof and notarize it with the help of TLS, and Bob will believe it because Bob takes part in the whole process. So it's like Bob will have reason to trust Alice because he took part in the key exchange and all the process when the data was generated. So most popular use cases is like, and I hope most of the hackers here are on the right side, like the KYC provider, creditors, data archive, or blockchain oracle. These are one of the use cases that where you can use TLS Notary. So why TLS Notary? It guarantees the data origin, data integrity, and data portability. Like I mentioned, you can transfer data from one website to another and prove it's authentic and has not been tampered with. With simple TLS, you cannot do this because in TLS, you use symmetric encryption between website and you yourself as a prover. So on your end, once you get the data, you can modify it, and Bob can question you that you modified the data. But with TLS Notary, you can't do that because Bob will himself take part in the key exchange and hold the process. That's the notary part. So this is some like what I explained. Like normally, you have the symmetric encryption between website and the you as a user or Alice. And you can't prove it to Bob because Bob will not trust the data because it's the symmetric key. You can change the data on your end. Like basically what you do on your website. For example, you can do inspect element, change the data, and just send that data to Bob. He can't trust that. With MPC TLS, multi-party computation, we use Bob as a verifier, Alice as prover, and you together take part in the key exchange. But for server, it's still the same key. For server, it's just one user. He doesn't know if they are Bob or Alice. For the server, it's just one user. Nothing changes for the server. It's just for prover and the verifier. Since verifier takes part in the key exchange, he can take part in the data encryption and decryption, but he can't actually read the data. And Alice cannot modify any data because as soon as the data comes, it gets encrypted with both of their keys. So there's a mutual trust between them because no one can cheat each other. Alice cannot modify the data because as soon as it comes, it's encrypted. And Bob cannot see the all data because it's encrypted. But it's on Alice if she wants to reveal what kind of information. So Alice has the whole capacity, like what kind of information she wants to reveal. So that's where the ZK parts come in. So in this example, for example, Alice can, instead of giving her address, she can just say, okay, I'm not in US. And that's a valid proof because it's generated from the website. For example, if she wants to prove she's 18 plus, she can just give the ZK proof that proof that she's 18 plus instead of giving date of birth. So that's why it's a like lack of better term, it's called ZK TLS2. So it has two parts, the TLS part, the notarization part, and the ZK part. Everything is open source, and the whole toolkit is in Rust and TypeScript. So we'll share the repo and everything that you can hack on. So we want to actually go in the whole live coding with all of you because we have only 20 minutes. But you can ask me questions later on that. So this is probably the most important link for you. It's a hackathon guide for each participant. You can follow. I would actually advise you to follow it completely before you actually start working on TLS Notary. So in the hackathon guide, you will have 3 examples, and I strongly recommend to complete all 3 of them so that you have better understanding of how TLS Notary works and how you can integrate in your project, or if it even makes sense to use it. So prove, redact, verify is basically you prove information from the website, you redact or hide the information, and you verify it to the third person. So same example, but this is with a notary and the Rust example. Same if you want to use, if you're familiar with Rust, go with this. And we also have the browser extension. If you're not familiar with Rust and if you want to do everything on the browser, you can use the browser extension. Same, prove, redact, and verify. Go through all of these 3 examples. The URL is there, and you will have better understanding of it. So I'm mostly work with plugins and browser extension TLS Notary team, so I will go more deep into that. So you can start with the browser extension demo, and there's a demo.tlsnotary.org. You just can go there, and it will guide you how to use the browser plugins. It's like a step-by-step game like that you can play. You can install the browser plugin, and it will guide you how to use the plugins. Again, this URL is also pretty important if you want to hack on plugins ecosystem. So some theory on how the plugin system works is, so TLS Notary plugin is a extension, is a browser extension that takes the cookies and headers and all basically reads your connection with the website, and based on that, it will help you to formulate proofs, and you have to make the plugins or by yourself. So extension is like it will have the request and headers. It will provide you all the tooling that you need to get the data from the website and generate a proof with it. But for each website, you have to write your own plugin. For example, if you are on Twitter and you want to prove that you own the Twitter account, you have to write a Twitter plugin for it. And the plugin system is pretty simple. I will go through that. It's basically follows a similar structure for each website that you can go through it. And it has basically 3 steps. It has 3 steps that you have to go for each plugin. The step 1 is to go to a website. Step 2 is to get all the cookies. And step 3 is actually to redact or verify and then generate a proof. Okay, so demo. Can I do live? If I have good internet, I will try to do a live demo. So this is the plugin that I made for the Axis Bank, which proves that I actually own an Axis Bank account. And then I can give the proof to a third party who might be a loan giving application. So I hope okay. So I'm currently running my own Notary server locally, but PSE also has a Notary server that you can use. It's in the docs. You can use their server too. If your laptop doesn't have enough resources, just use the online one. Oh, my balance. So this is the browser extension, and as you can see, I have 3 plugins here: Axis Bank, Twitter, and the Discord DMs plugin. So I'm on Axis Bank. There are 3 steps: visit the website, get the cookies, and start the notarization process. So it will go through here, as you can see. It got the protocol, started a session, and it signs it, and then you can see successful notarization of request. So what does this proof actually have? The proof mainly has the information that I own the Axis Bank account and what is my name in the bank account. It hides some information like my account number. And so it's still working because internet is super slow, but I have the recorded version too if it fails, just in case. And it can show how much money I have. And if I want to apply for a loan, it can just show the loan, the money I have and how much percentage I can get through it. It hides the address or other crucial information if you want to hide. And it's on the user how much information you want to reveal or redact. So you can do all of this with the plugin system. And I hope some of you make real world application like this where you use actual services that are in India, or banks or KYC servers or anything that is being used every day, that where you can want to export the data to some other side. Where's the presentation? So I was going to demo the Twitter plugin example, but unfortunately, Twitter changed their API. So the plugin system for Twitter is failing. So even if you are trying in the docs, it might be failing. So don't worry, you're not doing anything wrong. It's just the Twitter changed the API. But there are more examples that you can check here. So just to play around, so to get the idea how plugin system works, there is Discord DM examples, Fitbit example. I already gave the Axis Bank example. I will push the code later. I just made it today in the morning. So it's not that hard to make, to be honest. Okay. So for there's also a tool that I wrote. It's called plugin generation tool. So plugin generation, writing a plugin is a tiresome task. You have to go through a lot of requests on websites and to see which requests are relevant and which response are not for the proof generation. So I made this project, TLS in plugin generation. It's a LLM-based tool. All you have to do is chat with this plugin. You have to tell what's the API or which website you are on, and it will gather all the request and the response, and it will generate a code for you that you can later use to generate the plugin. So for example, we can visit Swappy. And I just have to, so in the official TLSN plugin, you won't have this chat window. This is added by me. It's still in early stages. So you can, wait a second, I have to start a server. Okay. So if you go with this plugin generation mode, you can go to any website. It will capture the current page, the API request, and the responses, and it will help you generate the plugin. So if you are stuck somewhere, maybe use this tool. So it will just ask you what's the API, and if you can, what do you want to notarize from this website. So for example, the website here is swappy.dev, and API is swappy.dev/API/. I want to notarize the response of the API. So it's basically like asking ChatGPT, but on the TLS Notary plugin. The difference is you get all the benefits of TLS extension. So you can, instead of manually copy pasting the request and responses to ChatGPT, you can just do it here. Also, you can't post every response or request to ChatGPT, first because of your privacy. Second, the request can be too big. For example, you request a bootstrap file, which is like 40K lines of code. There's no need for that. So it also filters all of these requests which are not needed. So it will only take the request and response which are needed for notarization. So in this case, it already it takes all of the requests, then it filters which requests are relevant to generate the plugin. So this is only needed if you are stuck with some website or if you need help with plugin generation. So you can use it. It's for disposable for you guys. And if I go here, like basically it filters what is needed, what is not needed, and then it sends the response, and then it will generate the final code that you can use to generate the plugin. Like here. It told me what requests are relevant to generate the plugin code. So it tells me I need a GET request. The URL is this, and it creates a request for me, and I just send that. And then it will generate the code. So code will look something like this. If you are doing plugin development, we have also bounties for plugins based on how useful plugin is. There are rewards for that. So the core is you will have mainly 3 files: index.ts, config, and index.d.ts. So this file config.json tells how the plugin should work. The step 1 is like you visit a website like Discord, Twitter, or your bank, or your government website, or Aadhaar website, any website. Second is collect credentials, like you want cookies, or how can you collect credentials? Maybe there's a JWT token. You have to specify that, what kind of credentials here are. Then the actual notarization and what kind of request you need to make. So this is just the workflow. And actual code goes here, the index.ts file. So you tell the step 1 where you have to go. Like for example, in this case, Axis Bank. And then step 2 was the collecting the cookies or however the authorization is doing. In here, Axis Bank uses session tokens. So I'm just getting cookies, headers, and I'm creating a request what is needed and what is not needed. And then this is the parse part where you redact the information. Suppose you want to hide your bank account number or maybe your address, so you can hide all of that information in step 3. It's up to you what you want to hide, what you want to reveal. And then the notarization part. And this is basically the workflow that goes here. So if you make plugins, you have to go through these 3 steps, and the code is available on example section of TLS Notary GitHub. Okay, where is it? So use cases. I hope some of you get inspiration from this. Identity is one big use case for TLS Notary. Like if you want to prove your identity to some other website, for example, you have your Steam achievements that you want to prove on, let's say, a statistic website. You can give your, instead of using the Steam API, you can just give the proof that you have all these achievements, and it will be valid. Financial, like I demoed for the Axis Bank, you can do it for your bank, HDFC Bank, SBI, or any other. Or maybe you can write a plugin that can generate for any bank. I'm just giving you ideas. It's up to you. Social, I already said, gaming and other stuff. So it's up to you what you want to make on. Like any Web2 data, you can make a proof on it and submit to another website. Or you can make a service where people can submit the proofs, and then you do some kind of work with it. These are the bounties. These are also mentioned on ETHIndia, just to gather your attention, like on which part you want to hack on. So there's plugin and the best overall use case for TLS Notary. So up to you guys. And these are important links, so make sure to go through Hackathon guide. Docs are very important. And if you want to use the generation, the LLM one that I made, this is the 3rd link, which can help you with the plugin development. Main code is in TLS Notary repo. So all the plugins, the Rust code and the TypeScript and the libraries are there. That's it. Thank you. I hope you make something fun with it. Okay.
Hello guys, so my name is Yash and I'm an open source contributor at PSE. And today this workshop is about building privacy preserving polls with Macy. So the objective of this workshop is to understand what is Macy, how it works, why do we need Macy, and a quick demo on Macy Wrapper, which is a quick way of getting started with Macy. It includes a front end and the smart contracts. So Macy stands for Minimal Anti-Collusion Infrastructure. So it allows a coordinator to create private polls which have a few properties. The properties include the polls, the votes of the polls are only accessible for the user and the coordinator. So only the user and the coordinator can decrypt it. And the votes cannot be edited, deleted, or censored. Also, there is no way to prove to anyone that this address has voted in a certain way. Also, it guarantees correct execution, so it cannot produce false output. Now, why do we need private voting? So voting in general is susceptible to bribery and manipulation. But if the briber doesn't know how the voter is voting, how you are voting, so it doesn't make sense for him to bribe anyone. Also, we have seen in many occurrences that existing public votes influence the new voters. So if you see a lot of votes are going to a particular candidate, you are more influenced to vote on that particular candidate. So private voting eliminates all of these issues. So going through the architecture of Macy, so Macy consists of a lot of EVM compatible smart contracts, a couple of SIRCOM circuits. One of the circuit is for processing the messages, so processing votes and verifying the validity of the votes. The other SIRCOM circuit is for tallying the vote. It validates the calculation of the summing of the votes. And then there are a couple of TypeScript utilities. One of them is the CLI to interact with the smart contracts and the SIRCOM circuits. Another is a smart contract clone written in TypeScript so that the coordinator can create the whole state of the smart contract on his local computer. And the cryptographic primitives that are being used here are Macy keys, which are EDDSA keys. And the encryption used here is ECDH, elliptic curve Diffie-Hellman encryption. And the hashing algorithms are used here. and ballots. So the user flow is as follows. The user first registers on the platform. While registering, he submits his Macy public key, which is again ETDSA key, to the Macy contract, and then he will be able to send the votes on the existing polls or the new polls, the upcoming polls on the Macy contract. So that process include creation of a vote message. That message will be encrypted by a ECDH shared key, which is a pair of a random key and the coordinator public key, and then this message is signed with the Macy private key. Now, after the execution of this poll, the results will be verifiable on chain after the coordinator has processed all the messages and tallied votes. So the Macy votes have a few properties. Every single vote message has a nonce, which can be used to track the order of the messages, and it can be used to change your vote later. So you can submit the vote again with the same nonce as you submitted before, and the previous vote will be replaced by the new vote. Now, every vote can also have weights. So we can have like a election where every user gets, let's say, 100 votes, 100 voting power. And then while voting, you can select 4 different candidates and give them 25 voting power each. So you can have something like that also there. And anyone, irrespective of whether you have signed up or not, you can vote. But only the signed up votes will be counted. And then the finalization process involves the coordinator first merging the sign-up tree and the messages tree. Then the Macy state is generated locally using the TypeScript contract that I described before. And then he would process all the messages locally, generate a zk-SNARK proof for this processing, submit this proof on chain with the commitment hashes, and then he would tally all the votes locally and submit the proof again on the smart contract. So anyone who has voted or not voted can verify on the smart contract the validity of the tally of the vote. Now, here are a few links. I will share this slide on the PSE channel on the ETHIndia Telegram server. And so basically, there are like 3 parts which you can look at of the documentation. One is the Macy GitHub repository. Another is the Macy platform GitHub repository. And third is Macy wrapper, which I'm going to show the demo of. So Macy wrapper, let me show this demo. So basically, I will share this link on the channel, but you need to first clone the repository. 1 second. I don't know if you are able to hear the audio or not. Please raise your hand. Okay. I'll just play this. audio connected here? Okay. It was not connected before. One second. One second. Okay, one second. One second. Headphone settings. Where? Speak. External headphones. Okay. Hilarious. Now that's why I really don't like this headphone setup. Okay. So I will just mute this and do a walkthrough. So basically, you first need to clone the project, and I will add these links on the Telegram channel. Now, after you clone the project, you will need to download the Z keys. But for saving time, I'm just gonna copy paste the Z keys from my computer. But once you run the yarn download Z keys command, you will be able to download the Z keys required for building this project. Now, so I'm just copying that. And then after that, this is a scaffold ETH project which contains two packages. One is the hardhead package, another is the Next.js package. So the hardhead package contains all the contracts, and this is the Macy wrapper contract. Now the Next.js project, the hardhead project also contains the deployed contracts.json file. As you deploy more contracts, the contract addresses will be updated here. You will also see a deploy config.json file just above the deployed contract.json file. So that file, you will need to add it once you want to generate proofs. So I will show that later in the video. So, and this is the scaffold.config.ts file, which would be present in the Next.js package. Now, in this package, you will be able to change the target network. So currently, it's set to the hardhead network, and that's why it will work on the local chain. Now, so after this, you need to create these environment files, and I will just copy paste one of the environment file from my computer. But basically, these two variables are required: the Pinata JWT and the Pinata gateway. So you will need to create a Pinata account to set up this project, and you will get this config. And the other two variables are not required, but you can add the Alchemy key for the better support. And also the Wallet Connect project ID is not required. If you want to support Wallet Connect, yeah, you can add that. And after adding those environment variable, you can start the hardhead chain using yarn chain command. The command is also written on the GitHub README. And then you can run the yarn deploy command to deploy these contracts. Now after that, you need to run yarn start. So yarn start will start the Next.js server for you. So this is the Macy wrapper project. So it's loading. Okay. So the first step is the registration. So when you will open this for the first time, it will ask for connecting through MetaMask. And after that, it would ask for the signature request. Basically, what's happening is the signature is the seed to create a key, a Macy key, and that would be registered with the Macy contract. So everyone who has registered using this process will be able to vote in the future votes in future polls. So, yeah. Then you can also see the contract addresses.json file here and the coordinator key pair.json file here. The coordinator key pair.json file is created when you are deploying the contracts. So it's used like it has the private key for the coordinator and the public key for the coordinator. We will need those later. Also, the deployer address by default is set in the hardhead config file on line number 74. So this address you will need to add to your MetaMask, or you can change the deployer private key using the environment variable deployer_private_key in the environment file to use the admin panel, which I will show in a second. So you can see on the top we have three tabs: home, debug contracts, and admin. the admin panel will only be accessible to the deployer by default. Now, on the admin panel, you will be able to see a create poll button, and you can create polls from here. So I'm just creating a dummy poll one with a random expiry and 2 candidates. Now, for poll types, there are 3 poll types which you will be able to see. A single candidate select, a multiple candidate select, and a weighted multiple candidate select. So the single candidate select is for like simple elections, where you just want the voters to elect for to select just one candidate, and for multiple candidate select, it will have check boxes, and it's like you will be able to select multiple candidates, the name suggests. And the weighted multiple candidate select is also like that. So every user by default get 100 votes, 100 voting power, and in weighted multiple candidate select, they will be able to allocate this 100 voting power to different candidates. Now for voting types, we have 2 voting types, quadratic votes and non-quadratic vote. I'm selecting non-quadratic for now. Then candidate names, C1 and C2 for now. And then the poll is created by a signature. So another thing, let me show you this error. This is important. You might see occasionally this error, internal JSON RPC error. This signifies that your MetaMask is having old state, and you might need to clean that up because it's a hard-hat MetaMask problem. So you will need to open your MetaMask, go in settings, and then go to advanced, and then clean the activity tab data. And then you will be able to create transactions. Okay, so the poll is not started yet. It would be started in a few seconds once you create it. So let me just skip forward. And I'm also opening one incognito tab for another user. And this is using a burner address, so you don't need to connect multiple wallets if you're using the Macy wrapper. It would create burner wallets for different windows. And you can add funds using the faucet. So the faucet button is on the top right. Then you need to register. I'm creating another poll because that one was expired. So the same poll, yeah. Poll is created. Now we can see those polls on the home page, and the polls have not started yet. So they have started now, and I'm voting for C2. And after that, I would go to the admin panel, and the poll status is still open. It would expire in a couple of minutes. So you can see on the screen the time was 31, and the poll would expire at 32. So I'm just going to skip forward. Then the coordinator, because the coordinator is currently responsible for creating the polls and uploading the proofs. So he needs to upload the tally file, which will display a chart. So this tally file can be generated using, again, some commands which are present on the GitHub README. So the last seven section contains those commands. So you will need to update the deploy config.json file for generating the tally file. Here you need to go to the specific network you have deployed to. So it contains all the networks. You need to go to localhost because we are currently using hardhat. And then you need to update the coordinator public key and the use quadratic voting flag. So this flag is by default true, but as we were using non-quadratic voting, we need to set it to false. And you can find these keys in the coordinator keypair.json file. And then after setting this config, you need to run these couple of commands. One is to merge the state tree and the message tree. So this creates the Merkle proofs. As it was second poll and the indexes are 0 based, so the poll ID would be 1, and we are merging that. So again, another important error to look forward is Hardhat doesn't mine blocks if you're not running transactions actively, but the poll is over, so you need to just create another transaction for it to create another block so that the voting period is over. So we would go to the scaffold ETH project, and we would use the faucet to add funds to the Hardhat, to add funds to this wallet. That creates another transaction. So once we have created that transaction, we can go back here and run the same command. So it merged the trees. And then we need to generate the proof. So for generating proof, this command can be used. You need to change the poll ID and the output directory for the proofs. Poll ID is 1. Output directory, I'm just setting it to output for now. And the coordinator key pair, coordinator private key, you can find this again in the coordinator key pair.json file. And then you can set the tally output file to tally.json. Now after that, it would generate the proofs, and you will be able to find the tally file in the Hardhat package. This is the tally file. We will upload that tally file on the admin panel. After uploading that, you can see the results. So basically, this was the demo. And now going on to bounties. So we have like $2,500 worth of bounties. You can scan this QR code to see more. And now to reach us, this is you can scan this to join our Discord server. Also on the ETHIndia Telegram, you will find PSC channel, and you can ask questions there. And here are some useful links. I will again share the slides on the Telegram channel, so you can find all the information there. Thank you.
It's shared, okay, good. Yeah. Yeah? Okay. Are we good to start? This is my timer? Okay. Hello everyone. My name is Raghavendra Ramesh. I work for Supra as VP of R&D at Supra. Today I'll be talking about Supra containers, app chains on layer 1. What? Can't hear? No, you need. Okay. Okay. Yeah. Okay. Today I'm going to talk about Supra containers, app chains on layer 1. Yeah, let's get on with it. Yeah, let's unpack what app chains are to begin with, right? And why app chains are popular. These are some of the examples of app chains. If you look at DeFi Kingdoms, DYDX, Osmosis, and the Uni chain, which is in the making. If you look at the TVL of all these chains, currently it's like 4 million on DeFi Kingdoms, 400 million on DYDX, and similar numbers for Osmosis. And if you look at Uni chain, which is not a reality as of now, but the potential which the Uniswap holds, the amount of money is around 4 billion. So, and it's moving to an app chain. So this shows that app chains are popular, and app chains are required for as a business model. Let's unpack what exactly is an app chain, right? Fundamentally, a blockchain dedicated to an app is an app chain, right? Or a group of related apps. But more importantly, what it enables is the criteria. App chain enables an app-centric business model. Let's say on a public blockchain, anybody can deploy a smart contract, right? And the users pay transaction fee that goes to the network. So what exactly is app getting out of it? Where is the business model coming in? Where is the revenue model being coming in? One has to bake in all the revenue model and the business model at the smart contract layer or at the Web2 front end. Can a framework be built at the blockchain layer itself, which kind of facilitates business model? So that's where the app chain came into place. As I said, it enables a business model for apps. Another salient feature of app chain is about sovereignty, right? It's not only the creator, it's not only the developers, it's the community around it. The users of this app, they get a sovereignty, a community, a control over this app, a communal control over this app, right? So precisely the tokens, the governance tokens and the app chain tokens facilitate such sovereignty, and these two are the fundamental things what we believe that app chain brings to the table. Well, these are at the business level. How does it boil down to technical level, right? So these are ensured via these four primitives. One is gated smart contract development, deployment. Sorry, it's a typo there. That means whenever a smart contract is being deployed, you need an approval from the admin of an app chain to deploy that. For example, you can't deploy a smart contract on anybody can't deploy a smart contract on DeFi kingdoms. You need an approval from the DeFi kingdoms community to deploy over there. And then the custom gas token. This is very important because that the fundamental primitive for business is whenever the user is interacting, getting the service from this app, he needs to pay with a custom token that is dictated by this app chain owner or app chain community. If that is so, then it gets traction and it gets the economic value for it. So the custom gas token is a salient feature that enables these primitive. So not only the token, why do the apps on any chain need to be restricted to get the transaction fee only in Ether or only in the native currency of any blockchain, right? They should be free to select their own token. Also, they should be free to set a price for their services. So this is custom gas pricing. So another argument that favors about for app chains are localized fee markets. That means if there is a hotspot on a blockchain state somewhere, the users of an app chain don't have to pay for that, right? For example, on Ethereum, if there is a hotspot, if there is some smart contract attracting huge traffic, the gas price rises for everybody. An app would easily argue that why are you increasing my gas price for my users given that I am attracting the same amount of traffic, okay, or my traffic has not jumped as much to substantiate for this much rise in the gas price. So that is where the localized fee market comes in. It is still a market because it's a business model. You would want to increase the gas price based on the demand, but demand to your app chain, right? So that's the localized fee market. So let's see we understood that the app chains are important and it enables a business model for apps and it grants sovereignty to the community around it. But what are the existing solutions, right? The layer 2 rollups, ZK rollups, subnets or shards, or these integrated ecosystems like Cosmos, Polkadot parachains, Avalanche subnets, and even as I said about L2s. So these are the current infrastructural solutions for app chains. The recent migration or the planned migration of Uniswap is also to a Unichain, which will be an Ethereum L2 based on OP stack. Yes, these are the current solutions, but we find that there is a huge limitations, delimiting factors for these app chains. It requires heavy bootstrapping. Fundamentally, we said it's an exclusive blockchain for an app, right? So that shows the burden of it also, in the sense that you would have to spin up a network. If you want a high decentralized security, you'll have a large network. So that means you'll have to enroll multiple node operators, multiple nodes to run your consensus protocol, run your app and everything. And also, so that bootstrapping itself is very heavy. Another important thing is how do you, for any app to be successful, you need to bridge assets, either it's fungible or non-fungible, to this chain from other chains. Because app chains are not general purpose blockchains, users will typically be using multiple blockchains and they'll park assets on multiple other chains. So it requires bridging, and bridging is a complex and latency prone and you know solution to move assets, and it impacts the liquidity integration. So users or the institutions will have to park or fragment their liquidity across multiple chains. This is definitely not a desirable feature at all. Oops. Okay. So we have the privilege of our CEO here in our audience, Josh Topkin. This is precisely the question he put to our Supra team. Why can't we support multiple app chains on a single layer 1 blockchain, especially on Supra blockchain? And he led the research, and the result is Supra containers. And we have the white paper up on our website. I would request all the interesting people who are interested in knowing more about Supra containers to have a browse of this paper. So let's begin to unpack Supra containers. In the rest of the slides, I'll try to show how Supra containers give the app chain experience on a layer 1 blockchain for multiple app chains, for multiple apps, as well as I'll also try to show you and argue that it goes beyond app chains. What are Supra containers? Fundamentally, it's just a group of smart contracts. Okay, there is no separate blockchain for an app. We are creating artificial boundaries for a group of smart contracts that are in the back end of any dApp. Okay, group of smart contracts typically belonging to a single application or a group of related applications. But that's not enough, right? We started out to give an app chain experience. That means we need to facilitate app-based business model and give sovereignty to the community. How do we do that? As we saw previously, we need to fundamentally break that down into these primitives. That means how do we realize custom gas token? How do we make the container admins set their own gas price? How do we enable approved or gated deployment of smart contracts? And more importantly, how do we enable localized fee markets, right? So the implementation is work in progress, and it's we have put out containers in our roadmap. It will come soon on our testnets and mainnets, but this would involve a widespread modification and widespread implementation. One has to modify the transaction structure because you have new fields now. There is no container concept at all in the public blockchains, right? You need to add this container field into the transaction. So also the custom gas token. The transactions, the way we interpret the gas is completely enshrined. Now we have to make available the kind of token used for transaction fee. Transactions targeting to different containers will have different tokens to pay for gas, so that has to be there in the transaction. Then the smart contracts have to be managed. We need to know which bundle of smart contracts are in which container and stuff, right? So that has to be managed. The biggest chunk will come in the runtime. In VM runtime, we need to deduct gas not in the native currency but in a custom currency. That means different currencies for different transactions targeting different containers and at a different price. So this requires modification to the VM, and so also the gated deployment, right? Typically in the app chains now, the deployment of a smart contracts happens completely, or the approval happens completely off chain, right? Now we have to bring that on chain as well. That means if somebody wants to deploy a contract on a container, he needs to get the approval from the admin of it. And to realize the localized fee markets, we need to enable some form of block space quota. Let's say if block space are are in the order of 100 million gas units, one needs to say, like, we reserve 10 million gas units for container 1, 20 million gas units for container 2, like that. Once you have such a quota system, then it enables localized free market. So these all are work in progress, and these are all make sense when you have a very high throughput system. Okay, the block space quota in a system where there is higher demand than you can accommodate is very counterproductive. For example, in Ethereum, you have the transactions in the mempool itself will take so much of time than the transactions that coming into the blocks, or the transaction that can be accommodated into the blocks. So we at Supra, as we have advertised multiple times, we are a all-in-one blockchain which is vertically integrated with multiple services. I'll come to that as well. And we have a very elastic network where we can accommodate the desired demand, or the input demand of traffic by elastically stretching the network. In this premise, we believe the containers makes more sense and more yields more benefit in such a environment. Okay. So as I said, the implementation is work in progress. The another big component of containers is about economics. Suppose we saw the two entities now, right? The container owner, or the app chain creator, and the users, right? This can be visualized as a private company. A company is offering some services, and the consumers are consuming the service. There's an interaction between these two. Now the economic model enhances when you take this public. That means you would want to allow public participation for investments, right? If somebody sees this company is doing very good, let me put in my money and get some profit share out of it, right? So that's where precisely the new concept comes in. It's about a new entity in the mix, is about lessees, block space lessees. Oops. Right. Yeah, here is where we allow anybody to come in and deposit Supra and buy the block space and allocate to their desired containers. For example, I might see that this container, we all have visibility, right? Which lending protocol is doing very good, which AMM is doing very good on chain. So these analytics are very visible. They're all out there. So one can invest in them, saying that I will say, for this epoch or for next 100 blocks, this container is going to be attracting great traffic. So let me buy block space for it and allocate for it. By doing so, the profits or the transaction fee that the user is packing into the transactions, that can be split into the container owner and the lessees. Okay, so that's where the profit sharing happens, and this is where we take the private company into a public company, or make the containers more economically viable. So our white paper is in the making. It will be out soon. So so the one thing to highlight is this completes the puzzle. The container technically as a group of smart contracts and the implementation plus the economics part of it is what comes together and makes a very very compelling case for business. Now what we have seen so far is like Supra containers is equal to the app chains, and I would want to argue that Supra containers is greater than app chains, and that is precisely because of this feature of composability, and this is what it distinguishes. Like here is a illustration of the way different containers could look like. So what's happened? Oh my God. Okay. Okay, here in the bottom we have a public Supra container. Public in the sense that anybody can deploy the smart contract. And let's say the container A, B, C are the permission containers. Yes. And all the white things are the smart contracts inside it. and the arrows are the method calls. So composability or a cross-container thing is, or cross-app chain or cross-container thing is no more than a method call here. So it's not at all complex because they are all being staged on the same chain, right? And containers can bake in their own access policy, right? To agree or regulate which kind of so to agree or regulate which kind of cross-container method calls they would entertain. So here is the here is the argument for the composability. Let's say in the case of app chain, if there are 2-3 app chains and they would all want to use a particular stable coin, let's say USDT, then the USDT has to be deployed on those chains separately, right? That would also mean that it fragments already the USDT's liquidity on across multiple chains. But in our case of containers, the USDT can be deployed on a public supra container, and all the containers can make use of it. Right? You don't need a separate deployment of this stable coin. It doesn't end with just the stable coin. It will go ahead with any lending protocol, a game. Suppose you are building a container specific to a DeFi AMM, but you still want to use it or expose your AMM to a gamify app or something. You can allow that to happen. So this composability or predictive markets, for example. So this composability is what it where supra containers goes beyond app chains, where even the projects which are not thinking of app chains can think of supra containers now. Okay, so just to wrap up in terms of what are the limitations that we overcome. As we said previously, the limitation of app chains were the fragmented liquidity. Because of this composability, we have a unified or we can provide unified liquidity. And also because we don't have to spin up new networks for each app chain, for each container, we have a cost-effective bootstrapping. The network is already there. You just have to deploy smart contracts there. Now, if you have even if you spin up a new network, you have to pay rewards for them to maintain the ongoing costs. Now, the same network is hosting multiple containers. Your recurring payments are so low or amortized across multiple things, right? And more importantly, you inherit the economic security of a L1, which is, in case of Supra, which is rooting for the highest decentralized security possible. But I'll not go through this. There is another aspect of parallel execution. I wanted to argue that container also serves as an access specification, which can be exploited for executing transactions in parallel across multiple cores. So here is here's an experiment that we did where we compared against Solana, C-level, EVM sequential execution, and Aptos block STM, and we showed that the specification of containers to yield benefits in terms of execution times is very promising. So here is the summary. Supra containers are app chains on layer 1, and they go beyond it by overcoming the limitations of of app chains via the notion of composability. And because they are hosted on Supra layer 1, they get access to native oracles through our DORA protocol, native randomness, the automation, and we have multi-VM support, the cross-chain communications all natively. So here is a takeaway message. This is a win-win for the network, so for Supra, for the consumers, and for the app creators. That's all. Thank you. We will be in the booth. I mean, if there is any conversation you would want to have, I will be available. Our Supra CEO is also here. We can take up there. Thank you very much.
Shall I start now? Shall I wait like 5 minutes?
Hello. Hello, am I audible, everyone? Can I get a thumbs up? Yeah, thank you. Okay. GM everyone, today we'll be going through the track prices at Polygon. Basically, this is a session called Polygon Tracks 101. I have no feedback, so if you're not able to hear, just do a thumbs down so that I get to know. Got it? Yeah. Are you able to hear, guys? This side, yeah. Thanks a lot, everyone. Yeah. So this is a guide on how to build on the Polygon track this year at ETHIndia. So basically what we are trying to do is consolidate all the resources and the GitHub repos that will be useful for you to build on the track. If you refer to our page, there are two important tracks that are there. AIX Crypto, which is basically focusing on-chain AI agents. And then next we have the ZK track, where we'll be awarding the winners the best DApp, ZK DApp that is hosted on the ZK EVM, Polygon ZK EVM. So during the session now, I'll be guiding you through how an on-chain agent can be built, an on-chain AI agent. For that, I'll be giving you some references and some strategies on how to build. So these are a few things that I've accumulated for you guys. The ChatGPT OpenAI team came up with the new assistant beta feature. So they have the whole page that you can check out, which is the assistant's API quick start. There's an amazing tutorial by one of our devs called Jared, who's making this tutorial. In this tutorial, they'll be teaching you how to build on-chain AI agents. So this will be that you write in a terminal, basically what transaction you want to execute, and that agent will go on for you, will execute that transaction. So for this, you have to use the assistant's API quick start. And first thing, you have to create an assistant. This is all in the OpenAI docs. And then after creating the assistant, one second. After creating the assistant, you have to create a thread and then add a message to the thread and create a run. These are the basic steps of how to create on-chain agents, AI agents using the OpenAI Assistants API. That's the basic thing here. We have also a deep dive section provided by them. I'll show you the GitHub repo that is for reference, that you can take for the reference purposes for this, which is an amazing GitHub repo that you'll find useful when you're building for on-chain AI agents. So let me go through the GitHub repo here with you. We have the OpenAI section here. It's taking a little time to load up. So let me give you an overview on basically what it is. As I told you, there are three things. You have to create an assistant, you have to create a message, and you have to then create a thread. So after doing all these things, you will be able to use OpenAI's SDK and then use that to deploy smart contracts and run functions on the smart contracts. So that's how it's going to be useful for you. So due to the internet issues, I'm not able to show you the exact repo right now. But basically what this is there are two sections here. The OpenAI folder consists of all the files that will be useful for building the on-chain AI agent. And then we have the VM. Basically, this is a tool which is used to deploy on Polygon. So the structure here will be to basically build deploy the smart contract on Polygon POS, and then use the OpenAI's Assistant API Quick Starter, and then build an on-chain AI agent. That's what the basic structure will be. All in the Telegram group, I'll be sharing with you all these resources so that you can have a quick look through and build an amazing on-chain AI agent which will be able to do transactions for your sake. So that's one of the things that we are building. To show you some quick references of how amazing on-chain AI agents are being built in the current ecosystem, I have a few examples which you can check out. You have to definitely follow this account called AI16Z. This is an amazing on-chain AI agent that is trying to beat the A16Z fund. So what this agent does is it executes trades on behalf of prompts, and then on behalf of you, and it works 24/7, and it's trying to beat the A16Z fund. It's an amazing Twitter account, and you can check it out for reference on how they have built it as well. This is one of the success stories that have come out in on-chain AI agents. To show you another example on on-chain AI agents, we have something called AIXBT. So AIXBT is a on-chain agent that is trained on the complete crypto Twitter. So the LLM is completely trained on crypto Twitter, and it is running 24/7 to basically analyze and research on crypto assets that are that need to be invested in. So you can check out the page of AIXBT as well, just as references to see that what great examples are there in the on-chain AI space today. So this is one example. AI16Z is an example. So how do you build these crypto on-chain AI agents? I showed you an example. You can use the OpenAI Assistants API toolkit. If that is, if you wanna use something else, there's another thing that you can use. It is called Brian AI. So it's something called Ask Brian. So you can use Brian AI basically. So you can see here, you can send transactions through prompt. You can deploy smart contracts to prompt. So this is one of the examples that has been built and deployed on the Polygon POS network. So this tweet just demonstrates that how the Brian AI is deployed on Polygon POS. And what basically Brian AI does is through prompts, you can execute smart contract transactions there. So let's go back to what we expect from the people who are building on Polygon track. The thing we are expecting, and the most important thing we have mentioned, is develop an AI agent to bridge access across chains connected to Aglia using the unified bridge. That's one of the main things we want. So let's slow down a little bit here. These were examples of like basics on-chain AI agents. But when you want to build specifically on Polygon, if you want more points and if you want to win the track prizes and want to make like great projects which will be useful in the future, you have to definitely know some about Aglia. Aglia is this new framework that is come up by Polygon, which is going to aggregate all the L2s and L1 into one and create a seamless experience for the user. So basically what Aglia does is this amazing diagram here. So all these chains on top are the L2 chains. They are connected using the aggregation layer, and then they are connected to the unified bridge contract. Aglia is making it easy for users to initiate cross-chain transactions. And this is through something called a unified bridge contract, which is on Ethereum. We have a great tutorial on the unified bridge by one of our DevRel engineers called Brian, and I'll be sharing the repository and the YouTube video of Brian as well. So that will be amazing for you to see, and then you can use that as a reference on how to build. So as I said before, if you want to build normal simple on-chain AI agents, that's good. But if you want to build something specific for Polygon, because Aglia is a new thing in Polygon, you can build the on-chain AI agents, ask them to do transactions cross-chain. So I will ask from chain A to chain B, I want to send a token using the unified bridge contract, and using the on-chain AI agent, make a front-end framework just by prompting it that I want to transfer this amount of USDT from this chain to that chain. It should be able to execute an on-chain cross-chain transaction. That's going to add a lot of value to your project from Polygon's perspective, because Aglia is the big thing that Polygon is betting on. And if you'll be the one of the first people to make a project on the unified bridge. So that will be amazing if you guys can pull that out in 2 nights, but it is a little hard. So just make sure that you need any help, come check us out at the booth and stuff like that. We'll be there to help you. For the unified bridge, because it's a particularly new thing, there's a whole repository called Unified Bridge and Bridge and Call, which is written by one of our DevRel engineers called Brian. It's an amazing repository which goes through everything you need on how to understand the unified bridge first of all, and how to build on the unified bridge. So I gave you a couple of examples of on-chain AI agents. So an amazing project will be using these agents to execute cross-chain transactions on the unified bridge. You can go through this entire actually this first part is just explaining what the unified bridge is, how it works, which is not needed for dApp level developers. It's more of a protocol level thing. But then when you go down, if you go to this part, is code walkthrough and how do we use the unified bridge, asset bridging and these kind of stuff, and references. You can see exact repositories and code that will be useful for you to develop the unified bridge smart contract. So again, I'll be sharing in all the references on GitHub for you guys so that you can look at it and build on the Polygon track. That will be great. So we covered, are there any like questions on the CryptoX AI on-chain agent part? Have you guys like understood? Can I get a thumbs up if you guys are following through? Like a thumbs up from everyone. Great, thank you. So I would like to sum up and give us a quick summary. On-chain AI agents, you can use OpenAI's SDK. You can use Brian AI, that's also an SDK. There's another thing called Goat AI. You can check them out as well. It's also a software development kit used for building on-chain AI agents. These three are pretty good. That's why I'm recommending them to you guys. And then you can use the unified bridge and do the cross-chain transactions. So CryptoX AI part track is done for now. So again, like this is one of the major things that's happening in crypto. So this is one of the track that Polygon has introduced. And another disclaimer and thing to be noted that these dApps for CryptoX AI should be deployed on the Polygon POS network. There are two networks in Polygon, Polygon POS and Polygon zkEVM. zkEVM will be mostly focused on extremely security kind of DeFi applications, but on-chain AI agents for now, you can deploy it on Polygon POS. That will be great. And for the ZK track, we need people to deploy on Polygon zkEVM. So that's basically the structure we are following. Okay, so this part completes our CryptoX AI. There's another track called the ZK track. As you guys know that Polygon has one of the best ZK teams out there. Polygon ZK team is currently developed a framework called Plonky 3. It's an amazing framework, one of the most fastest provers for zero knowledge, and it's modular as well. So you guys can check that out, Plonky 3 as well. So let's go back and see what we expect from the zkEVM and track as well. So we need you guys to create amazing ZK related products and dApps, and the resources you can use for these are the Plonky 3 that I first told you. Plonky 3 is developed by Polygon, is an amazing framework and a toolkit for you to use. There's this tutorial by Brian, which explains the Plonky 3 Fibonacci example, where we go through how do you exactly make constraints in Plonky 3. It's a huge process, and you can understand it to make great apps on Plonky 3. So I'm just showing this to you, but it'll take some time to understand this. So we have like a day or so, 2 days for building. So you can go through this entire repository and check out what exactly you need or to make constraints using the Plonky 3 framework. That will be great. And then to point out another thing, there was Plonky 2 before, which was the fastest proving recursion ZK framework. But then we have Plonky 3 now. The major difference between these two frameworks is Plonky 3 is modular framework. It means that we can switch two important things that are in ZK. That is a hash and a field. So currently Plonky 3 now supports these fields and these hashes. So why do we need to do a combination of fields and hashes? Basically depends on what you're trying to do with your ZK circuit. If you want a smaller proof size, if you want faster proving time, you need to alternate, and what kind of a ZK circuit you have. So you can switch and swap between fields and hashes and get the best efficient ZK circuit there. So that's one of the examples for Plonky 3. Also something you can use for developing on the zkEVM track that we have is SP1. Okay, so to go through what SP1 is a ZK VM, or something we call a ZK virtual machine. A ZK virtual machine is something which allows us to write normal code and then converts that code into a ZK proof. So the process of writing a ZK circuit is extremely tedious, and people who have gone through it will understand it's not easy. So what Succinct, which has partnered up with Polygon Labs, has done is made it very easy for people to develop ZK. Succinct's new SP1 is the most user-friendly ZK VM is out there, and through that you can write code in Rust, and then you can convert it into a zero knowledge proof. That's what Succinct's ZK VM is doing, called SP1. You can use this framework as well to build ZK dApps on Polygon on this track. So Plonky 3, We covered ZK VM called SP1. These are the whole ZK, the docs for SP1. They're completely very detailed and will help you go through how to set up SP1 packages and how to run ZK circuits there. So this is the most amazing thing out there. You can check this out as well. So after this, we will go through another thing called pessimistic proof. This is also an example, just repository I'm showing. It's something Polygon is developing for the security of the AG layer. It is completely written on ZK VM SP1. So this is one of the examples that we can give you of how to use SP1's ZK VM. Yeah. So after this, we have covered the ZK track. Basically, what we want you to do is, let's just go back and see one of the things that we have done. So there are 3 things you can use now. Plonky 3, we can use SP1, and we can use these 2 things for building our proofs. And we are also like encouraging you to build identity dApps. So how do you build identity dApps? There is something called 2 references given here called Privado and an Aadhaar. There are 2 private identity things that we can use, and we can use these to build proof systems for identity as well. These are also promoted during our track, and someone who's using Anan, Aadhaar and Privado will also be given an opportunity to win the ZK VVM track. So to sum up, finally, what I'm trying to tell here is you need to put these ZK dApps on this Polygon ZK EVM chain. So the CryptoX AI, the agents go on the Polygon POS chain, and the ZK dApps go on the Polygon ZK EVM chain. They're 2 separate things, and hackers need to keep in mind of the distinction that we are giving here. Okay. So I've summed up my complete session here. I would like to take any, are you guys clear with the stuff I've given out? Can you give a thumbs up or something like that so that I can understand? Yeah. Thanks a lot, guys. So 2 tracks, mainly CryptoX AI and ZK track. We'll be present 24/7 in the Polygon booth for any doubts and queries. We are taking doubts now, so if there are any doubts, can you please ask? Are there any questions on something that you want to ask, you're not understanding in the Polygon track, or you're facing any difficulty in understanding? Is there something like that? Okay, I'm there for another 2 minutes, then my session's ending. So basically build the best dApp, guys, and if there's an actual real world use case, you'll be getting the Polygon track. Yeah. Thanks a lot. I'll conclude my session. Yeah.
How can I connect this one? Like this. Can I connect this one? I don't know. Is there a cable or something?
I'll just go ask.
Yeah. So yeah, there's a converter, but like, is there a way to connect this? Oh, okay. Okay, all good. And the mic is always here, right?
Yes.
There is no alternative.
No.
Okay, all good. It's all good. Like if I cannot walk, then
Yeah.
it doesn't matter.
It works.
Yeah. Do I start now? So I guess we can start right now a bit. So yeah, I'm now starting. Hi everyone, my name is Talib. I'm a DevRel engineer at Straya, and we're building something interesting. And in this short session, I'm going to explain like what we're doing shortly, and then what our tracks are, and maybe like how can we help. So the Stray is essentially an EVM compatible ZK rollup on Bitcoin. And like, if if you're not aware of these concepts, I think first we should dive into what do these mean, and like we can talk more on these. So like blockchains are basically decentralized machines. It's like a combination of multiple machines that does some computation. It's a network of computers at the end of the day. And we're building these because we believe they're a new whole open world of privacy, innovation, and freedom. Even though we failed a bit, like since the launch of Bitcoin, still we believe there's a long way to go, and still we can achieve all these. And if you were to, look back on like how all these things started, like Bitcoin was obviously like the implementation. Like there were ideas of implementing a digital currency in the world after all the tech boom, and then like there was eCash, DigiCash, B-Money, Hashcash, like different ideas. Some of them being centralized, some of them their own trade-offs. But at the end of the day, people were searching for some new ideas to carry out all these operations in a more digital way. And then like the 2008 financial crisis hit, and then like the idea of Bitcoin was born. It got registered, and then the white paper, which we probably all of us know about a bit. If you're not, please go check it out. It's a really simple and nice paper. And then the Bitcoin white paper was published, and then like the client implementation got running in 2009. And like then, another keyword that we all know is the Ethereum. Like, we know Bitcoin is cool, but like Bitcoin is mostly used for the purpose of money. It's like you can submit money to your friends, you can receive money, send money, you can do a bit of programmability, but like if you want to build use cases of loans, if you want to build use cases of different stuff, then Bitcoin is not sufficient for that, because Bitcoin script does not allow you to do expensive heavy computation. Actually, like most of the blockchains don't, but like it's quite limited in that sense, and you can only submit money. So there was a need to do more stuff. There was a need to bring more parts of traditional finance into the ecosystem, like into these digital cash. So like the Ethereum basically enabled this. Now you can do with the EVM ecosystem and on the Ethereum like much more expressive stuff, much more general stuff, like any kind of DeFi primitives, like taking loans and adding some programmability, generating more and more token types and different stuff, even to the point that verifying ZK proofs, which are some expensive computation that you can utilize. So for example, we have our Bitcoin Lite client contract. It is a smart contract. It's basically just like Python or just like C++. It's a piece of Solidity code that runs in a set of computers and that verifies the execution of Bitcoin transactions. So like the Ethereum was born based on some needs, and this need was doing more with the money, like instead of just sending and receiving. So yeah, blockchains are cool. Like they're pretty useful. They have many applications as much as their EVM, their virtual machines allow, and they're cheap. Like compared to banks, like if you try to send $2,000 using some bank, then you pay like a huge ton of fees to the banks. But on blockchains, this is like, depending on the trade-offs and security, this is really cheap. And like some blockchains can also be privacy first, even though we don't see them too much. Hopefully we will see more. But like there are also caveats of blockchains. Like they're not really super enough as we want them to be. Like there is this famous trilemma called blockchain, like the scalability trilemma, essentially like that's how I call it at least. This is a trilemma, like the more computers you get, the securer your chain is, but then it starts to get slow or more expensive. Or like if you make a smaller chain that executes fast, then you basically leave out a bit of decentralization. So it's all these kind of trade-offs, and that's why they call it like blockchain trilemma. But like one solution that tries to overcome this at least is like not even to the sense that like you would think, but it in a different way is rollups. Rollups are types of scaling solutions in which you make a faster and smaller chain, but you also post your data into another blockchain that who can verify your chain execution. It is like, let's say I make a chain called T-chain and I make it a small network. Then people might be skeptical in the sense that, can these people harm our money? Can these people harm us in the way that steal our funds or whatever? So like all these stuff that you see in this event are just kind of scalability solutions essentially, especially if they're infra, who is trying to make a much secure and theoretically much more promising solutions. And one idea is rollups again. And rollups are like, you make a chain that puts its data into another chain, and as long as this other chain keeps preserving your data, then like everything is okay, because you can just use this other chain as a source of truth. And this other chain also has some computation that verifies your execution. It is like, I make T-chain, I post the data of T-chain into, let's say, Bitcoin, and then I also verify the execution of this T-chain in the Bitcoin as well. So as long as people don't touch Bitcoin or like don't break Bitcoin, then I can always verify that everything is correct to the public just using the Bitcoin, so that people can use T-chain more in a more better and securer way. Like they can trust me more, like. And this is the idea of rollups. Like you basically do some things faster and then verify it on another decentralized network, using the data and like perhaps building bridges. So if you were to like summarize this in a much humorous way, it is like a diagram like this. So it's like we post the data on Bitcoin, and then there's some code that reads this data, and then there's some code that takes transactions and then executes and then gets into a new state of funds and then just publishes new data into Bitcoin. So it is like we're using Bitcoin as a sort of a database, you can think of it. Let's check how many minutes I have. Oh, I have quite some time, that's nice. So yeah, this is the idea of rollups. You basically publish your data so that you don't you cannot hide any data from public. They're all public. People can always verify it. People can always be synced into what you're doing, always aware of what's going on. And even further, like they can also verify it using different techniques that I will come in a minute. So yeah, there are many rollups on Ethereum. Like if you go to the, this area, you will probably see a bunch of them as well. So this is particularly because like the researchers and the cool people in the Ethereum world decided to do so. Like they said, okay, these are the limits. The more secure we get, the slower we get as well. So let's do another chains. Let's bring these executions into, off-chain, do these in other machines, and then just verify them so that we can agree that it's all true. So this is the whole idea of, all these scaling solutions that you see all around in the Ethereum world. And there is no rollups exist on Bitcoin. It's like there are some chains that utilizes Bitcoin in one way or another, but there is no chain today in the world that uses Bitcoin as a data availability layer, that uses Bitcoin as a source of truth. Like we get side chains. Side chains are just, your regular chains that work, and they post little data like hashes or some little data to the Bitcoin. But, let's say one day something bad happened, and then like for example, you protested against COVID, and then you became all of a sudden unwanted man, and then you wanted to use a side chain. The problem is like side chains may, even worse, like side chains may try to, hold data and not give you data so that you cannot do transactions or anything like that. So there are no rollups exist on Bitcoin yet. There are some side chains, but we believe like theoretically rollups inherit the security of this other chain, so they're much more comprehensive and securer. So, and also like there's a reason for this. Like Ethereum has a bunch of rollups because it can. Like they're smart contracts. It allows heavy data posting. But if you look at the Bitcoin, then what you get is for example, Bitcoin script is an assembly-like language with many limitations. It is like you cannot post too many things because its block size is 4 megabytes in every 10 minutes in the average. So also like it is quite expensive. So per transaction you pay some fees, and the more data you post, the more you pay. So let's say you pay like, I don't know, 200 kilobytes, 300 kilobytes, then you pay hundreds of thousands, like hundreds of dollars or thousands of dollars. So like all this kind of stuff are the reason that rollups do not exist at the moment until but luckily like the innovation never stops. So this is why we are here. So we're at Stria team, we're building a rollup on Bitcoin. So if we were to, go over it again, like in the first slide, I was talking about like, these ideas like EVM compatibility, ZK rollups, and being on Bitcoin. So if you were to, fast forward and check back, so Citra is an EVM compatible chain that we are building. That means, any kind of Solidity code will also work on Citra because we are a type 2 ZK EVM. That means like we're fully EVM compatible. Your smart contracts will continue to work on our ecosystem as well. So we are able to onboard many devs and onboard many protocols just directly, very easily, instead of being like, alt VMs are also cool, but like we're EVM compatible in that sense. Citrea is a ZK rollup. That means we're also publishing zero-knowledge proofs and verifying them using Bitcoin. So there are two aspects that I want to talk shortly. Publishing zero-knowledge proofs is like, zero-knowledge proofs are kind of the execution proofs. It is like you basically write a simple program, let's say, and then you say for this particular input, this program just printing something like this. But people may say like, you may modify this program, you may lie to people, how can I be sure that you run the exact same program in the exact same environment with these values and then you get these values? This is one specific use case of zero-knowledge proofs. And in the ZK, like they're mostly used for compressing and verifying executions and also for privacy reasons. Here we are basically verifying that Citrea rollup, like the Citrea chain, is working as intended. And here is a proof for this that you can find on Bitcoin. So we're also publishing this onto Bitcoin as well, so that people can check themselves and see that like everything is as expected. This chain is functioning correctly, and you can verify it on these, on your own local environment as well. We're also publishing the old data so that people can sync. And there's also Clementine. Clementine is our bridge. So bridges are kind of goes like this, if I were to simplify. Let's say I make a T chain, and then someone decides to make a chain A, and we don't know if I want to use chain A, I need to put some money into it, but I have money in my own chain, so how can I going to do it? Like, it's essentially bridges are like moving money from one environment to another, because they cannot coexist in, like, money cannot be duplicated. It's not, it doesn't have quantum property, it doesn't have superposition or whatever. So the thing you do is like you basically trust someone or like use some algorithm to onboard your money from a platform A to platform B. And for this, we have Clementine. So in today's Bitcoin world, the way you move your money into other Bitcoin is you basically trust someone, you give your money into them, and then they generally don't steal, but there can be accidents. And you trust 5 entities, you trust 5 entities out of 7, or like 8 entities out of 9. We believe these are not secure enough, because like if the stakes are too high, then like these designs are like, can be dangerous. In fact, like there is some controversy going on in the Bitcoin world that, like, I don't want to talk very deep on this, but you can always search, or we can talk later. So we're building a bridge. This bridge also does ZK verification as well. Like we verify snark proofs optimistically. We can talk details after this session. So essentially we're building a state-of-art bridge using the BitVM idea. And using this bridge, like, people does not need to risk their custodial funds that much. Like, it's still not trustless, but it is a trust minimized bridge that you can get the best today in today's world. And it's on Bitcoin. Like every data is on Bitcoin, every verification is on Bitcoin as well. So it is on Bitcoin, for Bitcoin, to Bitcoin. And this is sort of a hilarious draw that I made like 1-2 hours ago. It's like so the above chain is Citrea and below chain is Bitcoin. And what happens is, like, we publish the dates of our chain into Bitcoin. And also when you want to move your funds, you basically use the Clementine. It is a ZK bridge on top of, it's a ZK bridge between Bitcoin and Citrea. And yeah, we basically optimistically verify ZK proofs. You only, there's a one-off and trust assumption. That means as long as one people is honest in the world, they can challenge. And as long as one people in the system is honest, then funds are secure. So you don't need to trust like 3 people out of 5 kind of setups like that. So there is always like, this is a huge improvement compared to, previous years. Sorry, I have 5 more minutes. So like we have a roadmap, and like in this roadmap, like this is an old version. So now we basically made the testnet live, and now we also have the atomic swaps going on. So we're basically expecting to be live in the Q1 of 2025, hopefully. So there are some slight delays to make sure that everything is working correctly and as secure as we believe so. So yeah, like this is how Citrea is, and this is how it goes. Oh yeah, one thing is bounties. So what are we doing? Like, what are we here for? So we basically present 2 bounties here, and one of them is like the experimental DeFi bounty. So because we're trying to make a secure bridge, and because we're trying to, utilize a BitVM-based ZK bridge, that means like we're basically making a much securer Bitcoin scaling solution today. And this is actually like, this can play a really huge part for Bitcoiners to, try to utilize the EVM world's ecosystem. And like on the EVM world, there are many like, different protocols. Like there are DEXs, there are lending borrowing protocols, there are yields, and like there's much more stuff going on, but like Bitcoiners cannot use these today. So when we go mainnet live, then ideally like they should be able to use some cool protocols to make these Bitcoins some revenue streams. Instead of selling their Bitcoins, they can just, stake it, or, give some loans using it and then take some USDT, whatever, these kind of solutions. So because of this, we need cool DeFi ideas. And one track is particularly for this. So, if you have a cool DeFi idea that Bitcoiners can heavily utilize, it's just EVM code at the end of the day. Just try to, optimize it and submit so that we can get use of it. And like, there's going to be like, there's a bounty for this, and like we can talk even further for it. We support cool builders to make companies and grow bigger as well. And the other one is particularly for Bitcoiners. This is a very specific track using the Bitcoin verification contract called Bitcoin Light Client. So if this kind of sounds great for you, then let's talk quickly after this session. Yeah, I guess this is the end. So one particular example, if I have some time. Yeah. Thank you. So if there are no if any questions, do you guys have? Yeah, there is one question, but I don't know how can I hear. Oh, okay. So how can I hear a question? Maybe you can come and then I can repeat the question and answer. Or okay, let's talk later as well. Okay, let's talk later after the session. Okay, all good. One thing that I could show you is how easy it is. This is just regular EVM code that you see here. If I were to make the theme white, just you can see it easier. Yes. Oops, sorry. My internet is probably bad. Yes. So you can just use your existing IDEs like Remix, you can use Forge or whatever that you daily use in the EVM ecosystem to deploy smart contracts. Any of these codes also continue to work, just some simple. If you were to open our testnet smart contract, it is just a regular smart contract that is also going to work on the other EVM environments as well. So if you're proficient with Solidity, if you know Viper or even Yule, you can just deploy those smart contracts and then go from there for this particular track. We have some documentation to kickstart this stuff. So if you go to our documentation and then check the deployment guide, we do provide some real short explanations and concise explanations on how to kickstart it. But you can always check more, ask GPT, just build stuff that works so that we can give bounty to you. And yeah, this is just the way to do it. And you can also deploy contracts using Remix by compiling it and then going for MetaMask and then deploying from here. So this is just the regular environment. So yeah, I guess this is the end of my session. And thank you all for listening. And I hope you all have a great hacking environment and hacking days upcoming. So yeah, thank you.
I know. Is anyone here for this? Is anyone here for this?
Or you can join this. There should be one more call, TP link 9459.
5G?
Yes. And the password is 666.
Everyone's gonna see it, I guess.
Oh, sorry. 666 590 20. Connected? Wi-Fi working? Amit? Just
Sorry, guys. Wi-Fi's not working. Yeah, I can't view my slides. Huh? Oh, okay. Which one? Or how do I connect to this? How do I know? This one? LAN? I'm trying to send a message first. Disconnect this really quickly. Sorry. Okay. Nice. It's not showing up though. Good. Hi. So I'm going to be giving a workshop today. Can people hear me? Is this good? Cool. I'm going to be giving a workshop today on building MPC applications. MPC stands for multi-party computation. I'll explain a very high level of how that works. And then this talk is going to introduce also this idea called digital pheromones, which I'll go into a lot more detail on, but essentially is this way of using multi-party computation for human connection, which is like a primary focus for us at Cursive and what we'll be also giving a hackathon bounty out about. So yeah, I want to first talk about this idea. So to introduce digital pheromones, first like multi-party computation. So the idea here is that essentially a number of parties, greater than 2, have some private data, and they're essentially trying to compute some sort of function over all of their private data, but only revealing the output of the computation. None of the intermediate results, none of the actual private data itself. And so this is a very simple thing, and maybe like an example of this is like some sort of matching thing between 2 people. Like if you want to see if you have, let's say, compatible like job matching or dating or other sort of things, you can run this as in a function where your inputs to this function are not revealed, but the output, like true or false, is revealed. And what are biological pheromones? So if you're not familiar, this is like this chemical substance that different animal species produce. And it's basically used as a way of coordinating between members of that same species. So there's like mostly like olfactory, but this sort of signaling is extremely useful. And we think basically like combining multi-party computation with like human-centric data can enable kind of a digital version of this. And so how I define digital pheromones is threefold. The first is it's a lightweight privacy-preserving signal, and we can just put this out, and this can be used to essentially, generate connection and coordination between different people. Second is that this sort of thing is fully programmable and verifiable, and so, using multi-party computation techniques, you can compute any sort of query or function you want, and you can have inputs to this be like ZK proven. And finally, for this to almost be like a an equivalent to biological pheromones, at least kind of on like a nature level. This ideally is happening on like a neutral peer-to-peer protocol. There's no specific server or specific like stack that this is tied to. It can just kind of exist like in a way that different peers can interpret this. And so how can we think this, how do we think this sort of thing could help with human connection? If you break human connection down into two problems of basically like discovering connection and then deepening it, we think it can help with both. So on discoverability, like right now, we're basically stuck with like AI algorithms, advertising markets, who, show us content or show us different people that we should meet. And these apps and services are often completely unaligned with us in that what they're actually hoping to do is to make you spend as much money as possible and waste as much of your time. And like, they actually do not care about like finding genuine connection for you. In fact, a dating app would rather have you stay on the dating app forever and keep paying them versus actually have you leave. At least like monetarily, that's completely what they're incentivized to do. And so the sort of cryptographic part of this is that on one hand, like we can actually have full ownership of our own data using tools from like signatures and zero knowledge proofs. And as a result of this, like instead of that just going to an algorithm or to these advertising markets, we can control how it's used and interfaced with using tools like MPC. When it comes to depth of connection, like existing social medias and these sorts of platforms for connection, there's no verifiability on anything that happens. It's a common horror story of like dating apps of you meet somebody and they're like completely different from what they say they are, because ultimately like you just like say things right now online. There is no sort of like trust or verifiability on this stuff. And in a similar vein, like we operate on most of these in this like billboard model where we just like post things publicly about ourselves. Everyone can see everything. And as a result, we often, instead of tending to like be who we really are, we tend to show off like kind of sanitized versions of who we are and sort of cater to the algorithm. And so in a world with MPC and more cryptography, like first off, you can basically prove and sign off on all sorts of different information to essentially ensure that like, we have verifiability on this stuff. And also because this information is private to you first, ideally you can actually share deeper personal information and actually, facilitate like more meaningful connection this way. And again, like you can basically use these tools, like these multi-party computation tools I was talking about, to basically discover both common and also complementary traits in a way that doesn't need to be mediated through a central service. So I'm just going to go through like a bunch of different ideas for what this sort of thing can enable. I'll skip through a couple of them because we don't have that much time. But the first is the idea of narrowcasting. So this is kind of the opposite of broadcasting. Instead of just putting out information to everybody and hoping an algorithm gets to the right people, you can essentially privately attest to the criteria that you want, like the criteria of person that you want to share this information with. And so this is nice in two levels. One is that the information that you get is almost like guaranteed to basically match who you are and coming from like verified people. And also when you send out information, you can guarantee that it is getting to people who will, it'll be most relevant to. And in this way, we can sort of have information dispersal in a way that's much more like aligned with what we want instead of an algorithm or some sort of advertising market. This is a kind of mathy thing. Another kind of like business angle here is that a lot of this technology enables basically more peer-to-peer connections between businesses and consumers. In particular, like a lot of what I'm describing right now actually is basically just done by Facebook and Google for us. They collect all of our data and they essentially serve as this middleman that connects businesses to consumers by saying, oh, this business wants X person, this person has, these characteristics, and then they just collect rent on this connection making. And, it leads to, goods being priced higher. It leads to, again, like, these things not being incentive aligned with what you want. And so these sort of tools, if wielded more like broadly, could essentially enable this middleman to be cut out and for either users to get paid directly for their data or potentially just for goods to be cheaper as a result of like not requiring expensive ad markets, instead just going peer-to-peer. This is kind of unrelated. Another one that I really like is basically like, at least like in the US where I'm from, like it's quite difficult to connect with your neighbors and the people that are in your immediate vicinity in like a really natural way. Sometimes it can be easy, sometimes it can be hard, but one really simple thing you could do is like in a specific like location or area, you could essentially find people with like overlapping needs or interests or abilities, and you can essentially do little like things like, hey, I'm at the grocery store right now, I'm picking up eggs, and it turns out actually 3 of my neighbors also need eggs, like I'm just gonna get some for them. And the use of privacy here is just that, like, I don't know, people aren't gonna try to like put their entire grocery list and like the chores they're gonna do in their house or different things they're gonna run all publicly somewhere. or necessarily all agree on like a single platform to do this. But in a privacy preserving world, you can just post a private commitment to this. You can just broadcast it literally within your like local distance, and you can just discover the overlap here. And like it's a very safe way of sharing this because, you know, like you're only going to see what you have in common. So there's lower risk of like judgment or other things happening. I'm going to go through some of the cryptography involved in this. I'm going to breeze through this because I'm not sure what everyone's familiarity with is, but I'm going to be at the PSC booth. It's on the like left side of the main venue, so please come by and talk to me if you have any questions. I'm happy to whiteboard some more stuff. So the first is a tool called private set intersection. This is essentially like kind of the simplest MPC you can do, where you discover things you have in common with each other without revealing anything else. And in this case, like something you can do is just like attest to different like interests or like people you know, things you like, and just output the like things you have in common. And it's this sort of like immediate icebreaker. And actually, we've built out a really simple version of this that I'll show you guys how you can use at the end of this presentation. And you can also imagine extending this to more parties. Probably the simplest thing here is just like calendar availability. Like, you know, you just, instead of doing this let us meet every single time, you can basically just post like, here are the availabilities I have, and then just discover what you have in common. And yeah, you never need to like share your calendar with someone else completely. One nice thing about private set intersection or PSI is that it uses privacy offensively. ZK as a tool, for example, is focused on selective disclosure. It's literally focused on revealing the minimum amount of information you can. And so even though it's privacy preserving, it's not very good for connecting with people because you're really actually trying to hide parts about yourself. PSI, on the other hand, like you're basically just seeing what you have in common. So again, there's very low risk of like judgment or some negative thing because it's something you both have, the worst case. It's very easy to understand and explain. I've worked on a lot of different cryptographic apps, and this is by far the one that, you know, someone who's outside of our space can quickly grasp and just be like, okay, I can believe this is a thing that happens. But unfortunately, it's quite rigid. It's like a very like specific protocol, and sometimes you would just want to express more things. And so that brings us to another tool called multi-party FHE, or also known as like threshold FHE. And this is a way of doing multi-party computation that requires lower liveness and compute. And so the kind of setup here, okay, I'll go through this in very high level. Basically, the setup here is that, actually, we're just going to skip this. We're not going to go into too much detail. If you're interested and you care about this stuff, please come talk to me. I just don't want to, you know, like waste people's time here. But essentially, like, I think the way to think about this is that it's a way of doing MPC in a way that, like, essentially a single server can do all the compute. So individual devices are not necessarily, they don't need to be like have very strong compute. And you can do this in a way that's fully privacy preserving. We've built out some apps with this, including like just the private set intersection. We've built it with multi-party BFV, which is a form of fully homomorphic encryption. It's just a very good fit for PSI. And then basically there's this one repo that we've been using called Phantom Zone. And it enables like this kind of like optimization on top of multi-party FHE called non-interactive multi-party FHE, which again, I will skip going into detail for now, but please come talk to me if you're interested in these things. Something we built with this was basically a private job matcher. So in this case, essentially, a recruiter would just post listings for a job, either private or public. And for the candidate, if you're, let's say, for example, as a candidate, you're hired, you're employed somewhere right now, but you're not happy, or you just want to see like what other jobs are out there and available for you. What you can do essentially is you can basically privately post, hey, like these are my qualifications, this is the stuff that I can do, this is how long I've worked. And you can also privately post what salary you're willing to work for, or maybe what salary you'd be willing to like change your job for. And what we can do is that we can keep all of this stuff private, and we can just notify the candidate about, hey, like X person has a job description that actually fits you. Like it fits your qualifications, they will pay more than what you've said you're willing to work for. And throughout this entire process, you can keep all of this information private. So the specific salary the recruiter is willing to pay can be private, the salary the candidate is willing to take is private. And generally, you can basically just have like both privacy preserving and also really efficient connection over, you know, two different people's like desires. Again, very little compute on devices required for this. I can go into more detail if people are interested. But the problem with this is that there's actually still a lot of back and forth rounds. And in general, multi-party computation takes like a lot of data transfer between the different parties. And FHE does away with a lot of that, but there still is like at least 4 rounds. more and more if you have more and more parties. And so this makes building apps really difficult because people put their phones away. And when someone's phone is put away, they can't actually participate in a computation. And as a result, basically, like, just the app stalls. The other big problem with FHE is that the involved public keys are enormous. Basically, like, can range from like 15 to 100 megabytes. And this means, like, for example, on ETHIndia Wi-Fi right now, like, you wouldn't even be able to like start the application because you need to first upload your public keys, and then you could do stuff. But then if the Wi-Fi is bad, or if you're like on data somewhere, you can't even do anything. So that takes us to Trinity, which again I will zoom through really quickly. Basically, Trinity is named because it's the combination of garbled circuits, a really classic MPC scheme, witness encryption on KZG commitments, and Plonk, which is a famous ZK snark. And basically, like, the two main affordances of Trinity is that instead of needing multiple back and forth rounds between the parties, you just need one round of data transfer. And I guess to be clear, like, Trinity is a 2PC scheme right now, so it's just between two different parties, which you can still build lots of stuff with, but we're exploring how to make it, multi-party. But in this 2PC, you only need one round of data transfer, compared to, like, for example, multi-party FHE, where you need 4 different rounds of back and forth and a server involved. And finally, you can actually attach validity proofs of your data to Trinity, which means that all the information that people are sort of doing a two-party computation over can be verified, and thus your computation can have like more integrity. So we're still working on Trinity. It should be released like in the next few weeks, and we think it enables really simple DevX and UX. You can build off like other ZK-proven data, like using these Plonk proofs. And the overall API here, essentially, it's very similar to narrowcasting, where you basically can like send an encrypted email to people, and they will only be able to decrypt the contents of this email if they match whatever criteria you attach. So for example, with the job matching thing I sent before, as a recruiter, you can basically send out some sort of like job description, and the only people that will be able to decrypt it are people who maybe like have a verified 5 years of GitHub experience and went to a top college in the US, or like, have some other degrees and stuff that you're looking for. I want to bring up trusted hardware as one counterpoint, which is that at least how I've defined digital pheromones right now, I think for the sort of ideal version of this, it needs to be something that is a neutral peer-to-peer protocol. You can still build versions of this with secure hardware, but it will obviously involve a server that has the secure hardware, and thus I don't think it's quite like digital pheromones, because like it isn't fully neutral. Like if that server goes down, then you can't do this sort of like private computation. Okay, how can you use this technology? So in everyone's swag bags, there's actually an NFC chip, like this green NFC chip. I don't have a photo here, I'm sorry. You can come by the booth for more questions. And you can actually try a bunch of this stuff. So the NFC chip is basically just to set up your account and start building a social graph by tabbing other people. You can then import data into this, and you can actually try a couple of different MPC-based experiences. The main one being private set intersection, but also some small queries on your social graph. There's also this idea of this like little flower garden, where basically as you meet more people and as you learn more and more about them, you essentially can grow your flower garden. And it can be this representation of the people you meet at different events and how deeply you've connected with them. And soon, basically, yeah, we should have a version of this. I'm not sure if it'll ship in time for ETHIndia, but we're working on basically having a full end-to-end version of digital pheromones, where you can essentially put in queries, get responses, and yeah, essentially go through this entire process that I've been talking about. How can you build on this technology? Okay, so for people that are interested in hacking on this, there's 2 main repos that we would recommend. The first is MPC Framework. So this is built by PSE, Privacy and Scaling Explorations. Essentially, this is a framework that allows you to build two-party computation applications just using TypeScript. So you don't need to know any Rust, you don't need to know anything else. If you can build web apps, you can build this. And under the hood, this uses garbled circuits. And there are a lot of back and forth rounds between the parties. But like, you can still build some like really interesting POCs with this. And notably, if one of the parties involved in the compute is a server, then the whole like rounds of interactivity thing isn't actually a problem anymore, because the server will always be online. So you can just do some compute there. There's a slightly simpler repo called two-party PSI that we've built out. And so this is just private set intersection. It uses this multi-party FHE that I was talking about. And you can also still build some really, really fun apps with this. It uses like Rust compiled into WASM, but to be able to use it, you just need to know TypeScript. There's a bunch of ideas that we've included. We have a bounty of $2,500 for people building projects on this. I'll share the breakdown on the next slide, but there's some peer-to-peer ideas of essentially like a lot of the stuff we've been talking about of like matching different people together with like compatible or similar tastes. Another fun thing is like a full private marketplace where you can sort of like do kind of an auction system of like, you know, X person has these goods and these interests, like can you match them together and essentially make like a fully private marketplace. There's also a lot of interesting like business to consumer versions of this where essentially like you want to like get advertisements matched with somebody based on some interest vector. So there'll be some server that's doing a 2PC on your data, but you get to still keep your own interests completely private and potentially even get rewards for this, whether it be coupons or just getting paid. There's also a lot of like healthcare related things. Generally, this is very sensitive data, and so stuff like insurance and hospital stuff. I was talking to one team today who's going to build this out. So if you're interested, I can also get you connected with them. And then yeah, we have 4 prizes. First place will get 1,000, and the other 3 teams will get 500. It's going to be entirely judged on just like creativity of application and smoothness of experience.